Good day, my dear grade 8 students. I know that you have started already the inequalities in triangle. You've done previously the inequalities in triangles and exterior angle inequality theorem. This time, we will open up another topic entitled triangle inequality theorem. It is still related in the inequalities of triangles.
Let us first illustrate this theorem. In triangle ABC, AB plus BC is greater than AC, and AB plus AC is greater than BC, and BC plus AC is greater than AB. Triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. We have to prove first how this theorem came up. Given the triangle MNR with the illustrations, we have to prove that MN plus NR is greater than MR. Using the two-column proof, we have the first column statements, the second column reasons. First statement, extend MN to point A so that NR is equal to NA. Reason, by ruler postulate or by construction. Number 2, NR is congruent to NA. Reason, definition of congruent segments. 3, angle 1 is congruent to angle 2, isosceles triangle theorem. Measure of angle 1 is congruent to measure of angle 2, definition of congruent angles. Statement number 5, measure of angle ARM is equal to measure of angle 2 plus measure of angle 3 by angle addition postulate. Statement number 6, measure of angle ARM is equal to measure of angle 1 plus measure of angle 3 by substitution. Then statement number 8, MA is greater than MR. Reason, if one angle of a triangle is greater than another angle, the side opposite to the larger angle is longer than the side opposite the shorter angle. Statement number 9, MA is equal to MN plus NA by segment addition postulate. Statement number 10, MA is equal to MN plus NR. The substitution from statement number 2. And lastly, MN plus NR is greater than MR by substitution from statement 8 and 10. By triangle inequality theorem, we cannot draw a triangle of side lengths 5 cm, 7 cm, and 18 cm since 5 plus 7 is less than 18. If the measures of the two sides of a triangle are given, we can apply the triangle inequality theorem to find the range of the values for the measures of the third side of the triangle. Let's have illustrative examples. Illustrative example number 1. Is it possible to draw a triangle with sides of 10 cm, 21 cm, and 35 cm?
Illustrative example number 1. Is it possible to draw a triangle with measurement of the sides 10 cm, 21 cm, and 35 cm? In order to answer that question, we need to use the triangle inequality theorem. It states that the sum of the two sides of the triangle is greater than the length of the third side. So let's try if we can really form a triangle with this measurement. So let's start with 21 cm plus 35 cm. Is it greater than 10 cm? So let's add 21 plus 35. It is 56 cm. Greater than 10 cm. Is 56 cm greater than 10 cm? Probably the answer is yes. Next, we need to check the combination, or that is the combination of the and 3 sides. Next, we already have 21 and 35. Let's have 10 centimeter plus 35 centimeter. Is it greater than the third side, which is 21 centimeter? Okay. 10 plus 35, we have 45 centimeter. Is it greater than 21 centimeter? 45 is greater than 21. So, probably yes. And lastly, we have 10 centimeter plus 21 centimeter. Is it greater than 35 centimeter? So 10 plus 21, this is 33 centimeter. Is it greater than 35 centimeter? 10 plus 21 centimeter, we have 31 centimeter. Is it greater than 35 centimeter? Yes or no? 31 is smaller than 35. That is, 31 is less than 30. 35. That means this is no. Right? This is the right. This is the right one. So therefore, only 2 satisfy. The other one is no. Therefore, we cannot form a triangle with this measurement. Let's draw if it's right. Okay, let's illustrate this triangle. If we cannot really form this triangle. Okay, let's have the biggest side, which is 35 centimeter. Let's draw here. Okay, 10, 20, 30, 35. So this is our 35 centimeter. Next, the second biggest value, 21 centimeter. Okay, let's have this. (21 centimeter). So 10, 20 plus 1. So that is our 21 centimeter. And lastly, 10 centimeter. So from here, we need to get there here. But since 10 centimeter, we cannot reach here. We only stop here. So therefore, this is our 10 centimeter. Therefore, with this illustration, we cannot really form the triangle that measures 10 centimeter, 21 centimeter, and 35 centimeter. It is no.
Let us illustrate it. So, look at the illustration. So, it is not a closed figure. So, therefore, it is not possible to have a triangle of side lengths 10 centimeter, 21 centimeter, and 35 centimeter. Illustrative example number 2. The measure of two sides of a triangle are 11 and 18. Find all the possible measures of the third side.
Example number 2. So we have this solution. Let x be the measurement of the third side. Okay. To find the possible value for the measurement of the third side, we need to use again the triangle inequality theorem. So, by using the triangle inequality theorem, these three inequalities that I will be writing must be satisfied. So, 11 plus 18 is greater than x. And letter B, 11 plus x is greater than 18. And letter C, x plus 18 is greater than 11. So, in first inequality, we have this. So therefore, 11 plus 18, 29 is greater than x. So the measurement of our third side, x, or we have x must be less than 29. And then, in our inequalities, letter B, we have x is greater than 18 minus 11. That is, x is greater than 7. So in equality letter B, we have come up with the measurement of the third side, x must be greater than 7. And then lastly, x plus 18 is greater than 11. So x is greater than 11 minus 18. So x must be greater than negative 7. Since there's no side that is negative, we will need to focus the intersection in these two inequalities. So we have x is less than 29 and x must be greater than 7. So we can combine these inequalities. We have 7 here, and then that is x must be greater than 7. So we have this, and x must be less than 29. So we have this also. So the measurement of the third side must be greater than 7 but less than 29.
Since all the three inequalities must be satisfied, we take the intersection of the three regions. Thus, we have x is greater than 7 but less than 29. Therefore, the measure of the third side must be between 7 and 29. Illustrative example number 3. You are to enclose a triangular lot with a fence. The measures of the two sides of the lot are 100 meters and 200 meters. What is the maximum total length of the fence that you need the fence?
Solution for illustrative example number 3. Let x be the length of the third side. So again, in example number 2, we need to have the inequalities using the triangle inequality theorem, and it must be satisfied that this inequality must be true. So let's have the first inequality. 100 plus 200 is greater than x. And letter B, we have 100 plus x is greater than 200. And x plus 200 is greater than 100. So, in the first inequalities, we have 300 is greater than x, or x must be less than 300. In inequality letter B, we have x is greater than 200 minus 100. So x must be greater than 100. In inequality letter C, x is greater than 100 minus 200. So x must be greater than negative 100. So it will not be included for the length of the third side. So we have the length of the third side, which is denoted by x, must be greater than 100 but less than 300. Therefore, the total length of the fence that needed to enclose the triangular lot is 100 plus 200 plus x, where x must be less than 300. So we have 100 plus 200 plus 300. So the fins needed is equal to 600. So the fins needed is less than 600.
Direction. Answer the following in a 1/2 crosswise sheet of paper. Number 1. Determine whether it is possible to draw a triangle with the given side lengths below. Verify your answers. Number 2. The measure of two sides of a triangle are given. Between what two values must the measure of the third side fall? Let h be the length of the third side. Show your solution. Number 3. Solve the inequality PQ plus QR is greater than PR. When PQ is equal to x plus 2, QR is equal to x minus QR is equal to 3x plus 2, and PR is equal to x plus 3. Assessment. Direction. Answer the following in a 1/2 sheet of paper. Number 1. Determine whether it is possible to draw a triangle with a given side length. Verify your answer with A, B, and C. A is equal to 4. The measure of two sides of a triangle are given. Between what two values must the measure of the third side fall? Show your solution. Let B be the length of the third side. A, B, and C. Number 3. Given triangle PQR, apply the inequality PQ plus QR is greater than PR to find x. Give at least 5 values of x that will satisfy the given inequality. A. PQ is equal to 3x plus 1, QR is equal to 5x plus 7, and PR is equal to 4x minus 2. I hope that you have learned a lot from my video presentation on the triangle inequality theorem. Learning doesn't stop here as this video ends. Rather, you can answer more problems on your books or in other sources. Keep learning. That's all. Thank you.